Welcome, everyone. My name is Marria Carrington, and my colleague Naomi Dupree-Edelman is here, our assistant director, and we're excited for this session tonight. It's session 2, and if you missed session 1 and did not sign up but are interested, please just reach out and we can send you that recording. And Naomi, I know you're going to still keep admitting people. They're popping up over here on my second screen. So tonight's all about addition, subtraction strategies. Probably mostly about addition. As I was planning and going through everything, I think I ran out of time for subtraction, so we'll see how it goes. But in our feedback slip, I could do a whole half hour on each of these. So if you want to come back for just a straight up subtraction session, we can make that happen too. So let's get started. These 2 books are a must when thinking about this topic, in my opinion. Today, we're going to think about how addition subtraction strategies in kindergarten to second grade through second grade specifically overlap with fact fluency to 20. And we're going to think about what each grade level can do to support the benchmark of fluency within 20 by the end of second grade. It is a big task to get second graders to that point, and it really takes all 3 years to get them there. So hopefully if you're a math coach here, this will support you in thinking about that trajectory. And if you teach one of these grades, it would also help you think about what comes before, during your grade, and after, or vice versa, depending on what grade you're in. So let's jump right in. So what do we mean by fluency? Well, there are a lot of definitions, but most agreed upon is that we want students to be efficient, flexible, and accurate. And this leads to them knowing their basic facts. I'll never forget interviewing a second grader in January, and the task was 13 minus 5. And she beautifully counted back 5 from 13. I interviewed her again at the end of May of her second grade year, and she told me she needed paper and pencil. And I was a little confused because I remember what she did in January because I had the interview in front of me. And I said, well, what would you do on the paper and pencil? And I can see some folks smiling, but she wrote 13 minus 5 in column format and then did some regrouping and ended up with 13 minus 5 again, right? And so something had happened instructionally from January to the end of May, which did not help her move forward away from a counting back strategy, but actually interrupted her learning and is now, doing the algorithm on a problem that the algorithm helps you in no way whatsoever. So we all agree that we want students to be fluent within 20. The question is, what is the path to getting them there? So that's what we're going to start thinking about today. So there's fluency, but then there's also addition subtraction strategies. And we're going to talk about both of those today. But simply, we mean by strategies is what strategy a student uses to figure out an addition subtraction problem. A memorized fact is not a strategy. We want students to be able to generalize beyond just the basic facts. For example, 3 plus 5 is related to 23 plus 5. It's also related to 30 plus 5. It's not that we just want them to know 3 plus 5. We're going to leverage that and build that throughout our number system. Same thing with 9 minus 4. It's related to 39 minus 4 or 90 minus 40. This is why we're not just teaching kids to just memorize their facts. It's not about just memorizing the facts. It's about the relationships and the concepts behind them. And this is what's so powerful, is that we can help them then make these generalizations. So let's think about how we're going to meet this benchmark of addition, subtraction, fluency by the end of second grade. We're going to talk about what K1 and 2 can do, and also what are the actual addition subtraction strategies relevant to each grade. I think a problem we sometimes have is we're trying to teach this fluency, but we're forgetting about where they are in their counting strategies or their addition subtraction strategies. So if we're pushing a non-counting strategy, but kids are still a count by one kiddo, where our instruction is missing where they are. So we're going to talk about that a bit today. So take a moment and read this for yourself. I think I touched upon this a bit already, right? We need to be doing conceptual understanding and reasoning, not just rote learning. So we're going to start in kindergarten. We're going to look at K1 and 2 and try to bring it all together. So if you saw my last session, you know I love sitting with kiddos and seeing what they can do. So I have 2 quick videos for you. These girls are actually not in kindergarten yet, but they are displaying some typical behavior for kindergarten. So we're going to think about, what do I mean by an emergent counter, a perceptual counter, and a figurative counter? What does it look like? So here's our video for our first counter today, who is perceptual. And then we'll unpack what we mean by that. So it's a quick little task. All right. Can you count all those for me? You can touch them, you can move them, whatever you want to do.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
So how many were there?
18.
Whew. As I said, a quick video. What is she able to do? I'm telling you, she's a perceptual counter, and she is able to count that collection. She has to see the collection, but she's able to count it effectively. She knows to touch one counter one time and say one word. And at the end, I asked her how many are there. She didn't go ahead and then recount that whole quantity. This is a classic perceptual counter. And I'm going to contrast her with the emergent counter, is the kiddo that wouldn't be able to do what she just displayed for you. So emergent counters are still working on their one-to-one correspondence. They may still be working on their verbal forward sequence. They may not understand that the last number they say, in this case, I believe it was 18, means the whole quantity. So there's a large range in the emergent counter. And we have a lot of kindergartners coming in as emergent counters, and we want to get them to perceptual, and then we want to think about figurative. And I'm going to show you an almost figurative example. This is a little bit of a longer clip. I want you to, she had already demonstrated to me that she was a perceptual counter. So I decided to change the task a bit and start covering up the counters to see what Bella could do. This is like a 2-minute clip, so if you want to take a little note. And I do want to say the last child, I did try this and she wasn't able to do anything with it. So take a look at what Bella is able to do. There's 4 there. I'm gonna cover those up, and 2 over there. Can you figure? I hid them on you. Can you figure out how many are there together? There's 4 here and 2 there. Is there anything you can do to figure that out? It's like a hiding game. Let me show you one more time. There's 4 and 2.
Plus them.
Oh, how would you do that? Oh. So how many over here?
4
and
2.
Okay, so how many fingers do you have?
6.
Let's see if you're right. Go ahead and count those.
1, 2, 3, 4, 5, 6.
Want to try another one like that?
Yeah.
All right. This time we have 6 here. Oops, actually, let me start over. That didn't do that right. This time we have 6 and 3. I'm going to hide them again. See if you can figure it out. Can you put those up here so we can see your strategy? How did you know?
I count the numbers.
Okay, what numbers did you do on your fingers?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, you think it's 9? Go ahead and count and see.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Wow. Okay, we're going to stop right there with her. The last task was 9 plus 4, and she wasn't able to figure that one out. But I will say she tried really hard. So when we think about what she's starting to do here, and I say she's almost to figurative, she makes the task actually perceptual by replacing the counters with her fingers. When she's no longer able to easily do that, when the task goes outside of finger range, she was not able to solve it. And a figurative counter can count what they cannot see and can take that outside of finger range. So they have a way to represent their thinking. Often it's by reusing their fingers, and they kind of know they can reuse those again. Whereas Bella was still needing, she was successful with 4 and 2. When she showed me her 6 plus 3, she adjusted and counted 3 out, and then counted 5 and 1 more for 6 and getting to 9. But 9 plus 4 was outside of her capabilities at this point. Now, no one had ever even covered up counters on her before. So the fact that she started to think about, oh, I can use my fingers, I can plus them. And this was a child that has a whole nother year in preschool at that family daycare. So to recap, kindergartners are counters. They come in, usually many of them has emergent counters. They can't yet count that collection successfully. Then our first student and our second student, they're perceptual counters. They can count a collection, they can perceive. And lastly, if we start making some instructional moves to start distancing the setting so they don't always have all of the counters to count, we can help develop them as figurative counters. So we need to keep in mind that kindergartners are counters. And so when we think about fact fluency, we're not talking about them counting to figure it out. We're wanting them to just know those answers through their experiences. So just keep that in mind as we keep going. First graders are actually still primarily counters. They are, they're actually developing. Some still might come out of K as emergent counters. And if you have counters who can't quite count a collection yet, as a first grade teacher, you have to be able to know that and work with them. Hopefully they're coming to first grade as perceptual counters and figurative counters, and we're trying to move them to being counting on and counting back. And this is a big shift that happens usually during the first grade year. And so what I've seen sometimes is kids are kind of told this procedure of put the big number in your head, and you actually sometimes see kids like tap themselves on the head or like put the number in their pocket, and then they start counting forward or backwards. We want to move away from that. That is like the kindergarten, first grade example of teaching a procedure or an algorithm, and that's not helping them conceptually get this idea that in technical terms, they can understand and hold that first quantity and not have to count the whole thing. And we call that having understanding of the numeric composite. They no longer have to count that first quantity, but they can move forward or backwards from that quantity and track their count. The thing that's tricky is usually kids' verbal sequences forward are beyond their understanding of the quantity. So you might have a kid that you say, count for me from 52, and they can go 53, 54, 55. That's a kindergarten standard. That doesn't necessarily mean that they understand if they have a quantity of 52 and you put 3 more, they can just count 53, 54, 55. So we don't want to tell them how to do that. We want to give them a lot of opportunities to count a lot of collections and games, and then think about they're adding 1 more or 2 more, and they're going to start to pick up that idea. Once they have this idea of counting on and counting back, that hopefully happens like mid-first grade, then we can start really helping them think about breaking those quantities into chunks. If they don't own that quantity as a quantity, and then we want them to think about 8 as, or if we think about 6 as 3 and 3 and use that in an 8 plus 6 situation, we're not going to have any success. So second grade, we know that they have to shift from counting by 1 strategies to utilizing composite strategies of breaking numbers into chunks. And that's how we get them to fluency to 20. So this shift in second grade can only happen if K and 1 have laid the foundation. So let's look at some of those, of what K and 1 can do to help build this. Sorry, kindergarten and grade 1, I meant to say here. So in K, it's this fluency to 5 and exposure to 10. And in 1, it's fluency to 10 and exposure to 20 in layman's terms, if your standards are based on the Common Core. So in the K-1 focus are on these 6 patterns. We're going to go through each one quickly. Wow, I'm already halfway then. Okay, I'm trying here. We're going to go through each of these quickly. And I want you to keep this in mind. In K, we're building and we're solidifying grade 1. When I say building, they've got the materials out. They are still counting. You may have some kids who start to remember some of these patterns and not have to count it, but they're primarily counters in K. So if we look about these first 2, patterns and partitions up to 5, we are thinking about what is the pattern on their fingers for 3, for 4, for 2, for 5? What does that look like? What does it look like on dice? What does it look like on dominoes? What does it look like on the 5 frame? And then we're going to start with patterns. What does it look like? And then we move to partitions up to 5. So if you see the red and blue image on the frame, that's a partition of 5. The kids have already know a full frame is 5. So now we're asking them, well, how many are blue? How many are red? Oh, 3 and 2 make 5. So we're starting to work on breaking apart that 5. So we're spending time in K working on these and also in grade 1. Grade 1, you want to dip back into 5, right? And in kindergarten, you're giving them so many different experiences with different materials with 5 that and not just 5, but with 4, with 3, so 5 and below. For example, we know they recognize these dot patterns pretty quickly if they've had experience. So if you use some color, this pattern of 5 can now become 4 and 1 by just adding some color contrast to it. And the pattern for 4 on the dice can become a 2 and 2. And let's link that to our fingers. Let's make 2 and 2 on our fingers. Is that still 4? We're giving them all of this concrete experience in K. One of the next things we want to work on, again, building K, solidifying grade 1, are our small doubles in 5+ patterns. So again, we're using our fingers. Our small doubles to start is right with 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5. We're starting there with what they have. We're then making it a little bit more abstract on the frame, so they can recognize that both of those are 6. The one on the top on the frame is showing the small doubles for 6. That one below it is showing the 5+. We also build our 5+ patterns on our fingers. We want to link those together. We also want to start building with the bead rack. And in kindergarten, make sure you get that 10 bead rack out or build them with pony beads and a pipe cleaner. You want to work within 10 a lot, but then you also want to double it up because they can't make the 3 and 3 pattern on a 10. They can make a 5 and 1 pattern on 10, but you want them also to see 6 as 3 and 3. So again, a lot of opportunities in K to build this, create games around it. And then as the teacher, you're trying to link the symbolic to it a bit as well. But you want to spend more time with the materials, with verbal thinking around it, with sharing what they're thinking. And then you start linking the symbolic. So let's go back to we've talked about patterns and partitions of 5, small doubles, 5+. And the next one we're going to think about is partitions of 10. Again, we're playing with these in kindergarten. We're solidifying in grade 1. So if you've built the pattern for 6, like we did over here, that top one, 3 and 3 is 6, and they were telling you, oh, there's 4 empties. Now they're starting to see it's a full frame. There's 10. There are 6 blue and 4 red. Kindergarten, a lot of them might still be counting when you start playing with this, and that's okay. But the more experience they have, and the more questioning you give to it, they're going to start moving beyond that. But they're still counters. So the expectation for them to just know this stuff by the end of K is not realistic. They're still counters. So I always tell kindergarten teachers, yes, your standard says fluency to 5, and you're building within 10. For a lot of kids, they might be able to tell you 3 and 2 is 5 because you've done so much with it, but it's not until their first grade year where they might be able to break apart 5 as 3 and 2 when adding 8 plus 5. So don't stress yourselves out, kindergarten. Work on it, build it. You are doing important work right there. So notice we did small doubles, 5+, and those can happen together. It's not that small doubles has to happen before 5+, but you just want to make sure you're really solidifying those. Then we jump to the partitions of 10 with the frame. And then we want to come back to partitions of the number 6, 7, 8, and 9. So again, we're building in K, solidifying in grade 1. So if we think about the frame that you see here as 4 and 2, instead of thinking about that, and this is more of a first grade idea, although I think you can have kids in K build it, but in first grade, it might move to the level of, you're going to flash this image. What did you see? I didn't flash it, but you think, what did you see? And they say they saw 4 and 2. And the question is, can you think of a pattern to help you figure out what 4 plus 2 is? And hopefully you're going to have some kids say, oh, well, I could just move that and see 3 plus 3. Or I could see 5 plus 2. Whoops, I forgot to take off that little dot at the bottom. So it should have been 5 plus 1. So 3 plus 3 or 5 plus 1. And so you want kids to start seeing that relational building instead of this as a completely separate fact. Wow, okay. To wrap up, we've got to use a lot of concrete materials for kindergarten wrap up in kindergarten. We're building these patterns. We're thinking about 5-wise and doubles. We're linking to our fingers. And you're adding to some symbolic notation, and you're beginning to distance the setting by using some covers like you saw with the little girl who started replacing with her fingers, or doing some quick images. Kids find that very engaging, and it helps them start build that muscle. First grade is working on all those same things. You're doing more distancing the setting. You're really solidifying within 10. And you're going to start really trying to use your questioning to help them link the symbolic to the visual. For example, if you're just showing them 3 plus 3 and kids start counting it, you might say, I want you to picture 3 plus 3 on your fingers. What number is that? Oh, it's 6. I want you to picture 3 plus 3 on the frames. What does it look like on the frames? Oh, 3 on the top, 3 on the bottom. And what number is that? 6. So you want to start linking them back to the images. So often we go from concrete, we have kids draw the picture, and then we put the symbolic, and we forget that in-between piece of linking the two, okay? Representational, if they're still drawing every object, it's still pretty concrete. They could still count it all by 1. So we need to switch that up a bit. All right, I want to give second grade a little attention. So just some research for you to consider about strategy groups outperform non-strategy groups, meaning a non-strategy group is like, let's just memorize these facts. Strategy groups retain facts better than non-strategy, and they can predict success in math achievement in general. So ultimately, the goal is verbal and symbolic fluency. Grade 2 has to help make that shift from counting by ones, because we don't want kids doing 8 plus 5 and keep counting up by ones. They get really fast counters. Then they go to the algorithms and they're still doing single digit by single digit counting by ones. We need to help them move beyond counting by ones in grade 2 so that they become fluent. So Jenny Bay Williams and John San Giovanni talk about these 3 main addition subtractions, so addition strategies. Others might call them something else, but I'm going to show you what some of these look like with the bead rack, because we need to think about how to make the strategies visual. It's not, I'm going to directly teach them 8 plus 5. You're going to do 8 plus 2 and 3 more. You're going to make your 10, right? It's not about directly teaching these strategies. It's about letting them unfold in the classroom, in the students, and then adding some language to it. And so we want to make it visual, so it's not just a trick that they are thinking they're doing. And so remember, the foundation has been laid in K and 1. So we're going to build on the frames, and we're going to build on bead rack. I'm going to show you some bead rack examples here. So near doubles, if we are building 8 plus 8 on the bead rack, what do we see here that they learned in K and 1? Well, first they need to be able to make that one push of 8. So they need to know that 5 and 3 is 8. That was a pattern that they worked on your frames, and hopefully you built that on the bead rack as well. They also, to solve this, hopefully see that 3 and 3 is a double that they know, and that 5 and 5 is a double they know. So if the work has been done in K&1, it's getting them to picture this 8 plus 8 in this way for them to know that it is just simply 10 plus 6. If you just did frames to 10, you want to make sure you've built these patterns on the bead rack as well. And now if we've got 9 plus 8, they can see the 8 plus 8 and one more. And we're wanting to draw that attention to what double can you see in this picture? So what is 9 plus 8? It's related to 8 plus 8. I know when I taught third grade, before I knew about this visual stuff, I would just verbally say, well, 8 plus 8. So what is 9 plus 8? It's one more, right? And I like kind of coach them through it. Like, no, they need to see it and build it and come to that understanding on their own. So making 10. I love this one. Think in your mind, how can we make a 10? And did you think about it this way? Did you push the 5 right over and see 10 plus 2? Or did you think about making a 10 on the top row and push over 3 and then 2 below? Here's the thing about bead rack. You can also make this a complete procedure. Don't do that. Let kids show you different ways to do it and let them notice what's happening. Otherwise, again, it's another procedure. So often I've heard people say, oh, you always got to fill that top row. And I'm like, really? Couldn't I just put 5 and see my 10 and 2 this way? I see my 10 there and 2 more. To do this, you have to have the understanding of 3 and 2 makes 5. Because you're breaking that apart. Again, that should be built in K&1. So it's not that one's better than the other. It's how do we open this up and let the structure of this material help kids move away from counting by 1. So they talked about near doubles, making 10, and then they call it pretend to 10. I don't really like that. To be honest, I prefer to think about compensation, but pretend to 10 means I'm going to pretend that 9 is not 9, but it's 10. And so I know I'd have to then change to 10 plus 5, or I might add 10 plus 6 and then take away 1 more. So that's compensation. It's making the problem easier for yourself in some way and then compensating at the end. 2 minutes. 3 main subtraction strategies according to these 2 authors is think addition, down under a 10, and then take from 10. So I don't have slides on those. I knew I was going to run out of time. Let me know in the feedback slip if you want to dig into subtraction. What I will say that I want you to just remember about subtraction, if we go back to just thinking about the frames, you want to build in questioning that has kids removing. So if you show this and they tell you it's 7, you can say, well, what if I took 2 away? How many would be there? 5. So the question you ask with the materials changes the task, as well as let's represent our partitions. You could think about the partitions. If I took away, so we have 10 here. If I took away the 4, how many are left? And you can then, show that as 10 minus 4 is 6. So it's a more of a part, whole, or whole, part, approach. Let me get back to, so we'll come back to these subtraction strategies in a follow-up. I hope a big idea for me in my learning around these topics was this idea of distancing the setting and thinking about how we can tweak the CRA model to have kids actually imaging rather than drawing everything and then counting by ones again. Kids need to live in that for a while, but then we as the teacher have to be intentional about helping them move away from that. So CRA, yes, but also distance the setting by quick flashes, by covering up the materials, by playing hiding games. There's all kinds of ways. I showed you really simplistic ways here in those videos, but there's all kinds of ways to make it engaging and fun. Thank you for coming. I'm Marria Carrington, the director here at Mount Holyoke. Please reach out to email or on Twitter. Also, I would really like your feedback. On the left is feedback for today. On the right is to register for our session on Saturday, November 18th. Please let me know if you'd like more information on anything from today. I know we didn't do much on subtraction. If that's of interest to you, please put it in that feedback form.